I was browsing the internet and I found this LiDAR, and I look at it and I had the idea, why not use this in a plane and use it with ArduPilot and measure the height while landing. And I did order a bunch of these, and later to find out that those are not compatible with ArduPilot. And then I had to do something with them, and I indeed find a workaround. Of course, by the end of this video, you'll be able to do it yourself. So stay here and see how it's done. And because the LiDAR, the DTS6012, it's not compatible with ArduPilot, I decided to do a workaround. And that means using an ESP32, like a bridge between the flight controller and the actual LiDAR. Of course, the spec of the LiDAR is pretty nice. It has a 20-meter range and 12 meter in full sunlight. It's pretty similar, and I would say it's a clone of the Binoki TFS20L LiDAR, which is more expensive, of course, than this one, but the spec it's pretty identical. This step it's optional, so if you already have the LiDAR enabled in your build, and if you have the last available firmware for your flight controller, you don't have to do this. So in my case, I did build it for Pixhawk 1, and it's the latest 4.6.3 ArduPilot, and I only selected the Binoki TFmini in our case, and I press build, and then I waited till build. So eventually it will get built, and with that binary you download it from here, you flash it to your flight controller. So another video for this will come, how to flash the firmware to your flight controller. Now if you go to my GitHub account, you'll find the schematic and the firmware, the source code for the ESP32, and as well all of the pinout for the ESP and the Pixhawk. The link is in the description. After you download the firmware from my GitHub, now you have this, and there are a couple of settings for different RX and RX pin, but the main thing, you'll have to go to Tools and then go to Board Manager and look for ESP32-C3 Super Mini, and then you select the COM port, and after that you hit upload or build, and it will download the firmware to your ESP32 board. After that you go to Tools and select the serial monitor, and you can actually see the data from the LiDAR. So I guess the hardest part of this project is to do some soldering actually, and here you see the ESP32 board and the Pixhawk and the LiDAR, also wires connectors for the Pixhawk to ESP32 and from the LiDAR to ESP32. So what I'm gonna do here, I'm gonna zoom in and you should see the board a bit better. I'll try to show you how to solder this. So first you go to the 5 volts pin, and this will go to the Pixhawk, so it will get the power supply from the Pixhawk connector. It doesn't draw too much current, so it's okay to power it from the Pixhawk. Here I'm trimming the wires. If they are a bit longer, then you should trim it down to be able to solder it on the pad. Yeah, so soldering the ground one. So now what I'm trying to do, because the colors inside the connector they are in the wrong order. So if you go from left to right, you'll have the plus 5 volts, which should be red, and the next pin it's the actual RX pin from the Pixhawk, and the last one from the right it's ground. So I will try to get the wires from the connector and switch them and connect them again, as I said. After all the wires are soldered and after you plug in the connector in the LiDAR, you are ready to go to test it, connect it to your computer, program it with Arduino IDE, and then connect it to the Pixhawk and see if you did a good job and did the soldering alright. This is how the setup looks on the table. I have the ESP32, the LiDAR, and the Pixhawk, and if I move my hand or if I move the sensor itself, I will see the data in the terminal of Arduino or in Mission Planner as well. Now the next logical step is to connect the flight controller to Mission Planner, and you select the COM port, you select the baud rate as I showed you, and now you go to full parameter list and you search for serial number 2 in my case, and you select the protocol for rangefinder, and for each changes you hit right, of course. Now you go to and search rangefinder number 1, and you'll have to select the type of rangefinder, which is in our case TFmini. Yeah, right. And then you go reboot your board, of course, and now you can see the data from the LiDAR itself. And if you want, you can also do a plot and select now rangefinder, and while I'm moving my hand on the top of the LiDAR, you actually see the real data on the plot itself. So this is a real distance that the LiDAR measures. Pretty nice, right?